Today, we're going to be talking about securing generative AI, specifically focusing on LLMs, kind of saving some of the other stuff for hopeful future talks. So let's dive right in. Only 20 minutes, and there's a lot of material to go over. I'll make the slides available afterwards as well, so people can have that. Quick background on myself. My name's Adam Swanda. I'm currently an AI security researcher at Robust Intelligence. So there we do a lot of model evaluations, creating defenses for different adversarial techniques, LLM red teaming, things like that. And I've been in the security industry for about 12 years, primarily coming from threat intelligence and security operations. Just left Splunk for Robust, actually, so spent the last 5 or 6 years there. And some of you might be familiar with this open source project I created called Vigil, which was an attempt at kind of combining a bunch of different detection techniques for jailbreaks and prompt injections. So that's open source on GitHub if you guys want to check that out. And so when we say generative AI, what is it that we're talking about exactly? So it's a type of machine learning that creates new content by learning patterns from being trained on large amounts of data. And then it applies those patterns over a probability distribution. So you're getting, the next most likely token for an input. And when you see, an LLM output, behind the scenes, there are actually lots of other tokens and texts that could have been chosen, and the probability of those, and the provider is just selecting the most likely token for you. And everyone, is probably familiar with the text models, OpenAI's GPT-4, Anthropic Claude. Those are the large language models. And then there's also image and audio models as well, so things like Midjourney, Suno is a popular audio one, or Udio is one that came out recently. And kind of putting the threats into perspective here, I've mainly been thinking about them in 2 categories, safety and security. The safety side of things relates to making sure that you don't have bias coming out of your models, that you can prevent toxic, harmful output, avoid hallucinations, things like that. While the security side of things that we'll be focusing on today are, the more kind of traditional attacks, adversarial attacks, insecure design, supply chain compromise, things like that. And this isn't an all-inclusive list either. I just ran out of room on the slide deck. So what do these threats kind of look like in the enterprise right now? This is a diagram of kind of an archetypical pre and post, pre-deployment and post-deployment pipeline for AI. On the lower right-hand side, you can see where it starts with, potentially using an open source model, like something from Hugging Face or Llama 2, ingesting public data and then deploying that model into an application. And I know there's a lot of information on the slide here, but the important part to take away from this, I think, is that each of these components introduces additional risk. There is no kind of one, solution to fix all of these problems. And, you do have to worry about the kind of AI-specific threats as well as all of the traditional application security, architecture, engineering issues that you normally would as well. And just as an example that some folks might be familiar with, prompt injection is a specific type of attack that can target LLMs, and the goal there is to override the instructions that the model or application has with your own instructions. So say the application is designed to only answer questions about taxes, for example. You could provide a prompt that told the model to disregard those instructions and follow your own instead, maybe write you some Python code or something else. So that's kind of one of the big, risks that people hear about: prompt injection and jailbreaks. And with retrieval augmented generation, which is pulling data from external sources into the context of your LLM, you also introduce the risk of indirect injection, where those data sources could have malicious content that your LLM is now processing. So again, just kind of a high-level view here. And how does AI security differ from kind of traditional security that we're all used to? Well, in traditional security, I think we're very blessed to have lots of logging and monitoring. Everything is emitting logs. Attacks are largely deterministic. So if you, use a particular exploit against a particular software version, that same exploit will very likely work again on that same version. This is not necessarily the case with AI, as the models themselves aren't deterministic. So you're not getting the same output for an input. A jailbreak attack that works for me might not work for you, but if you try it again, it could. And yeah, I think another thing to point out here is that threat actor interest in AI is still emerging, and I think kind of less understood than traditional software. There isn't a lot of motivation for threat actors to target generative AI systems yet, as I don't think they're in front of things that they care about. Like actors that want to do corporate espionage or spread malware are still probably going to do the standard methods until they need to change their techniques and target AI. But we are seeing a wide adoption of these types of applications, and there is some targeting of it already, so I assume that will continue. And the actor interest is kind of broken up into two camps as well. That is the malicious use of AI, so threat actors, using ChatGPT to assist their operations, and then targeting AI infrastructure, data, things of that nature. And the fun part about AI security is you have to worry about, everything on the right-hand side while also worrying about everything on the left-hand side as well. So that's fun. And here, just to kind of show some more examples, some of those might be a little hard to read, but it's broken up with AI-specific threats on the right and more traditional security threats on the left. On the left-hand side, we have some examples of software vulnerabilities in applications to, either deploy or develop models. And so we still have all of those same traditional vulnerabilities to worry about as well, right? If you have infrastructure that's serving models, those have to be secured. If you are developing a chatbot application, the Python library for that chatbot, is also potentially going to introduce vulnerabilities. And then in the middle here, we have a group that I think kind of straddles both, which is examples of traditional attacks that kind of target AI systems specifically, whether it's leaking, shared memory from a GPU, or targeting data scientists with model backdoors. And then over on the right, up top, actually that's a technique that Robust developed to algorithmically jailbreak models. And then on the bottom is a recent publication from Microsoft. They published alongside OpenAI, and this was about various APT actors, using ChatGPT, similar to how most of us use it for productivity purposes. So again, it's kind of twofold. Just want to make that distinction that there is kind of the AI side of things, there's kind of the traditional side of things, and stuff that falls somewhere in the middle. So what can we do about these new risks? A few things. I think an important part is to kind of get back to basics with application design. That's, doing things like threat modeling, making sure you know where your boundaries are and how data is being passed back and forth, sanitizing user input and output from the LLM, ideally having human in the loop where, you have to approve actions that the AI is making so it can't, autonomously add records to your database or something like that. At the same time, there is validation, which is kind of testing the models and the data sets, through the whole life cycle of deployment. So this is things like model evaluations, where you are basically throwing a bunch of data at the model to see how it responds, and then evaluating those responses, whether for, truthfulness or accuracy to some source document. And we do a lot of this at Robust. We do this for customers, we do this for open source models, and yeah, it's a little tricky to get right to, properly evaluate those validations, but if you can get it done in an automated way, you can identify failure modes and different vulnerabilities early on and kind of plan for that further down your development process. And yeah, once you've performed validation and you know what threats your model is vulnerable to, you can implement some continuous monitoring to identify and protect those assets. And yeah, this is largely going to be watching like LLM model input and output. The systems, the models and themselves aren't very verbose. There's not a lot of logging coming out of these, so we're kind of limited to that input and output. And yeah, threat intelligence, I think, is very important to stay on top of that as well. Threat intelligence for AI security right now is a bit different from traditional security too. There's not a lot of reporting on, in the wild threats. A lot of this stuff is going down on Twitter with researchers finding new techniques, or in Discord channels where jailbreaks are being shared, and lots of academic work. I read far too many archive.org papers to count, and that's where, I get the bulk of my like intel, so to speak, on new techniques that we should watch out for. So some changes there too, but I expect as these applications get deployed more, we'll start seeing more kind of traditional threat reporting. And we are also starting to see some emerging frameworks come out around AI security, specifically the NIST adversarial machine learning document, which is a big taxonomy of all the threats that I have previously mentioned and several more. It's a very good document. We at Robust co-authored it, so I don't want to toot my own horn too much, but I'm fond of it. And then the OWASP Top 10 for LLM applications is a really great community effort. They have voting out right now for the V2 of the top 10. So if you have looked at this document already and you feel strongly that some certain threat should be represented over another, or you want to add your input to definitions, up on their website you can join their Slack, you can fill out their surveys, contribute. It's a really great group of people. And MITRE ATLAS as well. MITRE ATLAS, has a lot of the same information as the NIST document and the OWASP document, but it is in the context of attackers using those behaviors, while the other two documents are more taxonomies of risk. And yeah, I'm quite partial to MITRE ATLAS. I try to reference it, and I think it kind of adds a little legitimacy to the reporting on AI security, just because MITRE ATT&CK is so widely adopted and so useful. I do think that Atlas can be that for AI. And lastly, the Databricks AI security framework, very detailed document, which has similar taxonomy information, but also information about kind of common design patterns and different controls you could implement at the different stages. And so looking forward, what do I think is kind of the future of AI and security? I think it's definitely going to bring some changes to the threat landscape. Attacks against generative AI models and the applications will very likely increase as adoption does. Right now, it's a lot of opportunistic attackers, just like seeing if they can cause some reputational damage by making your customer support bot say something racist. I think that's going to change in the future as these are used for more use cases that involve kind of the reasoning capabilities of the applications. I expect this is already happening, but I don't work at OpenAI, so I don't know. But I assume there's lots of intellectual property theft aimed at these state-of-the-art models. That is probably already happening. And another kind of trend I've seen lately is the introduction of autonomous agents, which are LLM applications that can plan and take multi-step actions to meet some kind of goal you give it, essentially. And they're really useful, and it looks like they could be really powerful, but at the same time they introduce a lot of risk, as for an agent to be effective, it would need to be connected to external systems, data sources, and be able to perform actions against those. So it gets really messy, threat modeling, that stuff. And yeah, ML supply chain attacks, I think, will become more common. We're already starting to see a bit of that with one of the articles I had posted on the earlier slide, where some models that are hosted on Hugging Face, had some pretty basic pickle backdoors added to them, but they're still there. I think these will just get more creative. And so that's all the scary stuff. So what does this mean for us, and kind of what can we do about it? I think one thing, if you're working security at your enterprise right now, it's really important to bring the AI and ML teams, into the security fold. What are they doing? What infrastructure do they have out there? Where are they getting data sets from? Are they using secure development practices? I've been very surprised at, past employers speaking to the ML team and, asking them, hey, are you considering this particular security risk or this safety risk? And it's, not even on their radar. They're just kind of working on the day in and day out stuff. And I think it really needs to be security that is at least partly, driving that and bringing that to their attention, like getting their buy-in, and hopefully, through monitoring, we can kind of alleviate some of the difficulties that they might have with deployment. And so that means, if they're developing models, you want to be doing a model validation or red teaming on it. Any MLOps infrastructure, ideally, you should be having, those emit logs, and you want to monitor those for attacks. Secure design practices for applications. And like I said before, anything that is deployed, you want some kind of continuous monitoring in front of it. Not just kind of the standard monitoring, but looking for adversarial inputs as well. One case or one type of attack in particular, availability attacks, for example. There are, certain attacks you can send an input to an LLM where the result of the attack isn't like a harmful output you get back necessarily, but it is actually the model using more energy to generate a response, right? So, like filtering that input is important for preventing attacks. It's not just the output. And community-driven security. What we're all doing here, I think, the cybersecurity community has a really great, history and kind of community built around it. We're all here for one. And I think we need to keep that going with AI. I already mentioned the contribution opportunities with OWASP, but DEF CON AI Village, they just opened their call for papers, I think, earlier today. Camless is another good one if you guys want to get involved in that or, attend any of the talks. And again, MITRE Atlas and the LVE repository are good as well. So I encourage you to, investigate these resources. I know a lot of this was high level, but I'm hoping that this is more an introductory for, people who aren't familiar with this topic and just kind of want to learn more, and we'll take some of these concepts and, go do deep dives when they get back home. So I think that's all I have time for. Thank you. If anyone has any questions, find me after. Yes. Yeah, you'd want to strip PII and stuff before it goes to, yeah, exactly. There's an open source tool that Microsoft makes, Presidio Analyzer. Yeah, it's really good for handling like PII, like sanitizing input and stuff. Yeah, I wonder the same thing. I'm surprised that so many people are using GPT-4 models in production, because that's just another place to worry about your data going, If you can use an open source model that does the same thing, I would probably recommend that, just generally. Yeah.
I have a question about the monitoring and the logging. It sounds like it's maybe a little bit nascent or early. And I wonder if, from your perspective, if anyone's doing it, they're kind of doing it by themselves, like custom on their own, or if you're aware of any solutions or models that folks might leverage to start thinking about that kind of thing.
Yeah, I think it's a bit of both right now. So like my company, for example, we have like a firewall that we put in front that does some monitoring, but there's also more like the observability side of things as well. So yeah, it is very early now. I mean, there are some open source stuff, like I'm not sure if you're familiar with like OpenTelemetry. There's a LLM plugin for OpenTelemetry, so you can get, LLM data into Splunk or something like that. I would plug my own application, but I guess it doesn't log, now that I think about it.
Well, thank you so much.
Yeah, of course.
Great talk.
There's been a lot of talk about you on the safety side. Are there any platforms that you can recommend that either incorporate or committed to ethical sourcing of models?
I don't know, to be honest. Yeah, the data sets around especially the bigger models, it gets a little iffy. If they don't release the data sets, it's kind of hard to vouch for them. Yeah, I don't know that we figured that one out yet. I mean, I guess it depends if someone's already building it now, but I could see something like productionized around that in 6 months maybe. I mean, I've been using LLMs to help write some kind of like threat reports and stuff like that, and using it for more or less full report generation from vulnerability scan results. So it is definitely possible. It's just that I think working with these models, they're very, finicky. It's like you have to spend a lot of time kind of orchestrating controls around it to make sure you get like structured output all the time. But yeah, no, I would not be surprised if we, saw that in the near future. Cool. I think that's it.
One question. Do you have a recommendation for like self-hosted LLMs?
Any scale is good. Oh, self-hosted like locally? Olama is really good. They kind of have like Docker files almost that define an environment. And yeah, or if you're on a Mac, LM Studio is good as well. I use both of those. They're both very fast. Awesome. Well, thank you, everyone.